Today's lesson is day 1 of lesson 13.1, Trigonometry, for Algebra 2. Trigonometry is made up of the two words
please come to the office.
trigonon, which means angle, and metria, which means measurement. So we are really looking at how to measure angles, or how to get the measurement of certain angles, but more specifically, the side lengths. Trigonometry is about the ratio of the sides of right triangles, and it's all based on their angle measurement. But what are the sides of a right triangle called? I'm sure you remember from previous courses that you have two legs and a hypotenuse. But with trigonometry, we can't call the two legs the same thing because we need to recognize that they are different in relationship to the angle that you're looking at. For example, if we're looking at the angle indicated by the red dot, is the leg that is vertical opposite that angle, or is it adjacent to it? Well, in this case, this angle here that is vertical, if I put my pen on the angle I'm referencing and draw a line, I intersect the leg that is opposite that angle. So from now on, I'm going to refer to that leg, not just as leg, but as the opposite leg. The horizontal leg is actually used to create the angle that is adjacent to the angle. So that particular angle, indicated by the red dot, has a leg opposite and a leg adjacent. But if I was recording this on my own paper, I wouldn't write it in ink because, let's say in the next problem, I'm asked to look at the angle up above. Now that horizontal side is now going to be the opposite leg, and the vertical leg is now going to be adjacent. It all depends on which angle you're referencing, and that's what makes each problem in trigonometry very different from the previous problem you did. To help us remember how to find our side ratios, a lot of people have used a fictional story about Chief Sokotoa. The story tells us that there was a young Native American boy who at times would struggle with schoolwork and struggle with math, and he would get very frustrated with it when he didn't understand. And one day he became so angered by the math problem he was working out, he kicked his foot into the ground. Well, little did he know that just underneath the ground surface was a big rock, and he stubbed his toe terribly on this rock. The toe just became red and swollen, and he caused a permanent injury.
Myers, please come to the office. Josh Myers.
He caused a permanent injury that really plagued him the rest of his life, and the only way he was able to get any relief from his terrible swollen toe was to go soak it in the cool river. Well, years went by, and school became easier for him, and he learned to love math, and he loved many subjects, and he became one of the most learned men in his tribe. The elders then decided that they would appoint him the chief of their tribe because he was such a learned person. And as they thought of his special chief name, they realized that everyone knew him as the person that every day would walk down to the river and soak his toe in the water. So he became Chief Sokotoa. Now that truly is just a fictional story, but it helps us remember the acronym SOKOTOA that leads us to our three trigonometry functions: sine, cosine, and tangent. Sine of an angle is calculated by the opposite side length divided by the hypotenuse length, thus SO, S-O-H. Cosine is calculated by taking the adjacent side length divided by the hypotenuse, the ka part of SOKOTOA. And lastly, tangent is TOA, opposite length divided by the adjacent. Let's see how these work with individual problems. In this problem, if I asked you to find the tangent of angle A, the tangent ratio, I should say, of angle A, you will calculate the fraction 7 over 5, because that is the opposite side divided by the adjacent side. That is the tangent ratio. Sine is calculated similarly with this triangle. Sine is the opposite side divided by the hypotenuse. So sine of angle A's sine ratio is 5 over 12. And lastly, cosine. Cosine is the adjacent side length divided by the hypotenuse. But what would the measure of angle A be? Well, that's something we'll figure out on a different lesson. Let's move on ahead with this lesson. Each of those three trig functions, which should be a review of what you learned in your Algebra 1 year, actually have reciprocals. So there aren't just 3 trig functions, there are 6. Cosecant is sine's reciprocal. So you're going to flip opposite over hypotenuse for cosecant, and it'll become hypotenuse over opposite. Cosine's reciprocal is secant, and tangent's reciprocal is cotangent. And you see that each of those calculations for the ratio is simply the reciprocal. So here's an example like question number 1 and 2 on the worksheet. They will give you two sides and they'll indicate theta. Theta is frequently used, that Greek letter, when you're using trigonometry and you're trying to find, or when you're referencing an angle measure. Well, if we are going to be asked to find all the trig functions, all 6 for theta, I need this missing side. And the way you find a missing side on a right triangle is the Pythagorean theorem. Just be careful as you work out the Pythagorean theorem that you remember when you're squaring that hypotenuse, you're squaring the square root of 17 and you're also squaring 4. So my missing side is 2. So I'm going to label the triangle and now I can start working out each of my trig functions. However, always reduce all your fractions. So as I look at sine of theta, 2 over 2 will cancel out. Now I have 1 over square root of 17, but now we have a more challenging problem. But you learned how to take care of the situation in Algebra 1, but what we have now is a radical in the denominator. And this is what I would tell you, that this is bad manners in math. We just never leave a radical in the denominator. It's like burping without saying excuse me. We just don't do it. So to rationalize our denominator, that means get rid of the radical in the denominator, I'm going to multiply that fraction by another fraction that means the same thing as 1. The fraction I'm going to choose to use is square root of 17 over square root of 17. Now when I multiply my numerator, 1 times the square root of 17, I get square root of 17. But when I multiply the denominator, a radical times itself is simply itself, 17. So we've just calculated the sine of theta. We reduce the fraction, we rationalize the denominator. Cosine would be the adjacent side divided by the hypotenuse. Again, simplify the fraction, rationalize the denominator, and you now have evaluated cosine of theta. Fortunately, the tangent one in this case doesn't have any radicals. When we reduce our fraction, we're done. To complete the 6 trig functions, let's look at the reciprocal of the 3 that you already knew. Reciprocal of sine is cosecant. Simply flip that one upside down. Reciprocal of cosine is secant. Flip that one upside down. And finally, tangent. Now you have all 6 trig ratios for theta. The next example is just like problems number 3 through 6 on your worksheet. They're going to give you one of the 6 trig ratios, and you have to find all of the others. Well, you know tangent is opposite over adjacent. So I'm going to write any right triangle I feel like drawing and label theta and the opposite side and the adjacent with the 3 and the 4 that are given to me. Using the Pythagorean theorem, I now can calculate the hypotenuse. Now it becomes very similar to what I had in the previous problem. I have all 3 sides, and I can calculate sine, opposite over hypotenuse, cosine, adjacent over hypotenuse. Tangent's already been given, so let's go on to the reciprocals. Cosecant is 5 over 3, secant is 5 over 4, and cotangent is 3 over 4. So you've now seen the original 3 trig functions that you learned in your geometry year with their 3 inverses and how to calculate them.